Yeah, look, Azmain.
Yes, sir.
Azmain joined 15 minutes back in another class. Isn't it,
Ah,
Azmain?
Bhuvai joined
MashaAllah.
In another class, I had another class with younger students, class 8. He joined in that class. So Azmain,
Sir, classy.
yeah,
They ask you क्यों?
Azmain, yeah, class 8 we have lots of
Yes,
students.
sir.
Like every class,
MashaAllah. मतलब आपकी class खाली.
I have around 10 to 12 students, 13 students. They are joining every day.
Sir, done.
Okay,
Writing
look
down, sir.
here, Azmail, oscilloscope. This heading you write, and draw this diagram.
Okay, sir.
Then you write this part, the underlined one, red color one. Now, after finishing this, you have to draw little part of this. You see, in last class we also told you that here we have two plates. One is X plate, another one is Y plate. Y plate is connected to voltage. You see, Y plate is connected to voltage. Here is volts. And X plate is connected to, see, X plate is connected to time base, time divisions. So you will draw this one. I am giving you this. So this part you draw. This is a cathode ray tube. CRT. This is called CRT. And after drawing this red color part, you draw only Y plates, X plates. Then show the connection with time base for X plates. Show the connection for Y plates with voltage. Okay, volts per division. That's it. We'll do this. Okay. Other things you do not need. We already had them before. So Aisha
Assalamualaikum,
joined.
sir.
Walaikum salam. Aisha, you write this. In last class, you wrote
Yes, sir.
oscilloscope and you drew this diagram. So you write this. The underlined one you write.
Sir,
Then you draw the part I gave red color in the
Okay.
right side diagram. And inside it, you give here X plate and Y plate drawing. And
Okay,
you
sir.
connect Y plate with voltage, volts per division, and connect X plate with time base. That's it. Only this much you need here.
Okay. Sir,
Yes.
we will have our city tomorrow.
No. CD I will take later
Monday.
because
On
from
Monday?
school they gave us the deadline for city 12. Okay. And if we take it on 9th, it is okay. No problem. 9th will be
Oh,
after 2
okay.
weeks.
Thank you, sir.
That's a
fine?
really long time.
Yeah, that's why we are not in a hurry for test. You just finish topic 24 nicely. That will be awesome.
Sir, test on topic 23, right?
Topic 23 and 22 is structured part only.
Okay, sir.
That's going to be
That
on
will
9th.
be on 9th of October. That will be fine. When we will
No,
be done with this theory part, then you have the test. That will be nice. Is it okay?
okay.
Okay, sir.
Now finish your topic 24 first, then we
Done,
will go
sir.
for test. Okay.
Done, sir.
Are you done with right side drawing?
Yes, sir.
Then Aisha, you are also done, right? Drawing right side one. X plate is connected to time base, time per division. Y plate is connected to volts. Do it,
जी sir, continue करता हूँ.
Completed?
जी sir, continue.
Okay, very good. Now, look what we do with this oscilloscope. Already we know some. Let us go for more little bit discussion. Can you please read here, Moshi? Moshi, what can oscilloscope measure more?
Bolen, sir.
Here, from here you read. What
Okay,
can
sir.
oscilloscope
What can
measure more?
oscilloscopes measure more? In addition to measuring voltage and time, many scopes have measurement tools which help to quickly quantify frequency, amplitude, and other waveform characteristics.
Okay, look here, we have uh, time. If you know time period, then you can find the frequency, isn't it? So you can
স্যার
find
আবার
the,
বলেন বুঝি নেই
if you know the time period, what is the formula of time period and frequency? F equals 1 by T, isn't it?
Hmm.
Yes,
Yes,
sir.
sir.
So if you know time period, then you can find the frequency, isn't it?
Yep.
Yes, sir.
So amplitude here is the voltage. So if you are getting the voltage, you can also find the amplitude, vice versa. If you get voltage, you are getting amplitude. If you are getting amplitude, you are getting voltage. Is it clear? So
Yes,
So
sir.
with the
amplitude refers to voltage, right?
yeah, voltage, yes. So the
That means
y-axis,
if amplitude.
yeah, y-axis is our voltage, right? The
Hmm.
y-axis is always showing you the amplitude, isn't it? Hello.
Yeah, yeah.
So
Yes, sir.
Yes,
so
sir.
if you
Continue,
are
sir.
getting amplitude, you are getting the voltage. That's it. Now,
Sir, do we have to draw?
no, no, not necessary, not necessary. This one you know, not necessary. Now, Aisha, you read this part. Timing characteristics.
Okay. Frequency and period. Frequency is defined as the number of times per second a waveform repeats, and the period is the reciprocal of that number. Of that number of seconds each repeating waveform takes. The maximum frequency a scope can measure varies, but it's often in the hundreds of um,
Megahertz,
million
megahertz, mega
megahertz,
range.
1 E6 hertz range.
Yeah.
দেখতে পাচ্ছি না।
Okay. So this one is whatever we discussed just now. That if you know the time period, then you can find the frequency, isn't it? Already we discussed this. Now voltage characteristics. Will you continue here?
Okay. Voltage characteristics. Amplitude. It is a measure of the magnitude of a signal. There are a variety of amplitude measurements, including peak-to-peak amplitude, which measures the absolute difference between a high and a low voltage point of a signal. Maximum and minimum voltages. The scope can tell you exactly how high and low the voltage of a signal gets.
Okay, this is also known to us, right? If you know the amplitude, you can find the voltage. We have for alternating current, we have positive and negative voltage, isn't it? Hello.
Yeah.
The lower part is negative and the upper part is positive, isn't it? So amplitude, from where we are calculating amplitude? From the middle, isn't it? From here till here it is amplitude, right?
Mm-hmm.
And here it is amplitude, right? So we have in one complete wave we have two amplitudes. One is for crest, another is for top, isn't it? In general wave properties we learned it, huh? Class 9.
Yes, sir.
So we have upper amplitude, we have lower amplitude. So voltage is also, for the upper amplitude it is positive, for lower amplitude it is negative. It is alternating voltage, isn't it? Hello.
Yep.
So this one already we know. In alternating current generator we got that idea. That's why we are not repeating the same thing again and again. And now we are having color code, measuring resistance of resistors using color code. Can you remember in our physics lab we did some experiments with electricity, where you got the resistors with color bands on the body of the on the body surface of the resistors. There are some colors, blue color, red color, green color. Can you remember them?
So I guess last year.
Yeah, last year we did.
red cello, যেগুলো use
Yeah,
করেছিল red
red
cello.
color,
Sir, am
blue
I right?
color, yellow
Last year,
color,
November,
different colors are
December,
there.
we did this.
So we are going to learn little bit about that color code. Can you please write this heading, measuring resistance of resistors using color code? Please write this heading. In in this note, I gave lots of discussions, but you don't need so much. You need only little bit. That one I am focusing now. You write this heading, then I will tell you. Here we go.
So let's see here.
Okay. Look here. Here only for this heading, you write a single line. I'm saying you. This line you write only. Here it's written this. Other than this, you write the. Only write the. The colored printed bands produce a system of identification generally known as a resistor's color code. This line only you write. Are you done with writing this? No.
Done, sir.
Sir,
Yes, sir. Done.
Okay,
sir,
now, yeah. Tell me, yeah.
before we continue, may I ask you something which is related to a different topic?
Yeah, you can ask me later. Let us finish. I will give you last
Okay.
5 minutes for asking. No problem. We have last till 12:25, right? So at
Yeah.
12:20, you give a reminder. Okay.
Okay.
Look here. We have this one to be focused. Okay, here. Calculating resistor values. This one will be only in your O level. This part. Only this part. This part is important for your O level, and
Sir,
after
লিখবো?
no, not necessary to write everything. I'm telling you how to write and what to write. You first listen. In your exam or in your past paper questions, if you go through, then you will find that uh, after 2 or 3 years, the questions are coming, and they are coming in a way. They will tell you this color. In a resistor, we have yellow, violet, and red color. Uh, three bands. Three bands is given, or they can say you they are brown, then they are orange, they are blue, or green. Any color they can give you. And not only they are giving you the color name, they will also tell you for each of the colors what should be the number they will give you. Okay, if they are giving you brown, orange, green, then they will tell you for brown number is 1, for orange the number is 3, and for green the number is 5. Now how to deal with them? How to work out with them? Look, for the first band color, in resistor we have colors, three colors, and these three colors we have to use this way. First band, first band you should write the number. Yeah. If it is yellow, it is 4. They will give you in the question paper. They will give you the chart. I will show in the worksheet also the sample question. For example, they are giving you yellow, violet, and red, and they are giving you the numbers. For yellow, it is 4. For violet, it is 7. For red, it is 2. Okay. And how to calculate the resistance? You have to write for the first two bands, only write the numbers. For first band, it is 4. For second band, it is 7. Then for the third band, you have to give power of 10. The third band is red, which is 2, to give their 10 square. So your answer is coming 47 multiplied by 100. 10 square means 100. So 4700 ohms. 4700 ohms. Is it clear to you? So
Yes, sir.
is it clear? Now if I give you 3 colors, I am giving you now 3 colors. One is brown, another one is orange, another one is green. So I am giving you here, I am writing brown. You will tell me the number, answer you will tell me what is the resistance coming. Brown I will give you, but it is 1. Then orange it is 3. Then green, it is the third band is green, it is 5. Can you calculate the resistance? How much it will be?
13 into 10 to the power 5
10 to
ohms.
the power of 5 ohm.
Yes, so this way you have to calculate. That's it. Can't you do this?
Sir, will the chart be given? Color
Yes,
code table?
this chart will be given. They
Okay,
will
sir.
give you not the whole chart. They will give you for brown it is 1, for orange it is 3, for green it is 5. This will be given.
Oh, okay,
So
okay.
that is also like chart, isn't it?
Yes, sir.
So you can do it, right?
Yes, sir.
Okay, now you please only write this part. For example, after writing this heading, you write this part only. For example, a resistor has the following color code markings: yellow, violet, red, and 472. Only this part you write. That's it. Not the whole thing. At least you can remember what you did. If you don't write, you'll forget, right? Isn't it? If you write, then you can remember. Yeah, Azmain. Hello, Azmain. 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 Moshe,
Yes, sir.
are you writing?
Yes, sir. Done.
Okay, so this one is your homework. Brown 1, orange 3, green 5 is given. So you find the resistance.
Okay, sir.
Find the resistance. This is your homework. Already Yakin told the answer. However, you write it as homework.
Okay, sir. Now my question.
Okay, now it's 12:20. You tell me what you wanted to say, Aisha.
Sir, this is about electromagnetic induction.
Yes, tell me please.
So, electromagnetic induction is when a change in the magnetic field produces a potential difference or a voltage across a conductor. This
Mm-hmm.
sentence is correct, right?
Yes, yes. It's
So, like
fine.
magnetic induction basically means the current or does it mean the voltage, the current of the voltage, which is specifically referred to?
Yeah, listen, in electromagnetic induction, we are getting first EMF, isn't it? Induced EMF. So if anywhere you are getting the EMF, there must be current, isn't it?
Okay.
And this
Yeah.
current is also induced current because it's coming from the induced EMF. Is it clear now?
Yes, sir. Now.
Okay. And this induced EMF or induced current is coming from the motion. Either you have to move the magnet or you have to move the conductor, isn't it? You
Yeah.
can remember the first diagram I gave. Uh, that diagram we had only one where that one was moved uh, inside the magnet, isn't it? And that one is moving the conductor. So by moving the conductor here, we are getting the deflection in the meter, isn't it? Ammeter or voltmeter or any meter you are giving, there you'll get the deflection. You'll get the reading. That shows that because of the movement of the wire, we are having here induced EMF. Is it clear?
Yes, it's clear now.
And then we got Faraday's law of induction, where we got that the coil is in stationary position, but we are moving the magnet towards the coil. If you are taking the magnet towards the coil, you will get the EMF in one direction. If you are taking away from the magnet, then you will get the uh, induced current in opposite direction.
In opposite
That one is
direction, like
that one is
negative and positive.
yeah, that one is more explained in Lenge's law, isn't it?
Yes, sir.
And after that we had alternating generator. Using the Fleming's right hand rule, we understood the direction of current and how the slip rings. There is slip rings, not split rings. Okay, slip rings are helping us get the alternating current because the induced EMF or the current produced is changing the direction because of the rotation of the coil inside the magnet, following the Fleming's right hand rule. Is it clear?
Yep.
And we
So also
got
could you explain
yeah
this?
yeah we got this one with more explanation in AC generator graph, different positions, how the EMF is increasing, how the EMF is becoming negative, how it is becoming positive, how it is becoming zero. We got details over there in AC generator graph, isn't it?
I don't know, sir.
And at the last in electromagnetic induction, we got transformers. We got primary, we got secondary, right?
Primary and secondary.
Yeah, and how the primary and secondary coils are related with the formula. We gave one formula VP by VS by VP, then NS by NP. If you
And
have
NS
more,
by NP.
yeah, if you have more number of turns, then you can have more induced EMF over there, right, in the secondary, isn't it? And we got also why we are using high voltage in the grid lines. Okay, why we get or we give high voltage in the grid lines to get less energy loss, isn't it? By understanding from the formula, power equals voltage into current, isn't it?
Yes, sir.
So these all are available in your notes. Please go through again and again because these things are complicated. Most complicated part of your syllabus is this electromagnetic induction and electromagnetism both. So if you are not going through again and again, if you don't, sharp your, learning again and again, you will forget again and mixed up. When it is mixed up, then it will be messed up, isn't it? You will be confused. So you have to go with my notes again and again. And I tried to give you less notes. Less notes means notes which is mandatory for you, not anything extra, which is a must to learn. Okay. I did not give you detailed notes. Okay, I just gave you which is enough for you for your O level. Okay, so don't skip anything. Don't skip anything. You learn everything from my notes. Okay, thank you so much. Anything more?
Understood. No, sir.
Assalamu
That
alaikum,
was
sir.
all.
Allah
Thank you,
Hafiz.
sir.
Assalamu
Assalamu
alaikum.
alaikum, sir.